So today we're going to look at the second half of lesson 13.1, which is on trigonometric functions and the reciprocal functions and trig ratios of special right triangles. So we're going to use information from yesterday's lesson in today's lesson. But a trig function is a function whose rule is defined by a trig ratio. A trig ratio compares the lengths of two sides of a triangle. So in this particular case, you see this triangle here, and we're using this Greek letter. It's called theta. And so the Greek letter theta is used to represent the measure of an acute angle in a right triangle. So that's just one of the many Greek letters that they like to use. They'll use theta, beta, alpha, but we're going to use theta today, so that's probably new to you. But this is called our angle right here. This is our angle of reference, or our reference angle. According to this angle, this is the side opposite, this is the side adjacent, and this is the hypotenuse. The hypotenuse can never be called the side adjacent, or in our case, we like to go the leg opposite, leg adjacent, and the hypotenuse. So if you always identify the hypotenuse, then the other two are either opposite or adjacent. So as I'm touching this angle, opposite would be directly across, right? So A is your leg opposite. And then as I'm touching this angle, this side is adjacent to that angle. So this is the leg adjacent. So I'm just going to abbreviate them as you see here. So sine is always opposites, the leg opposite over the hypotenuse. So as I stated earlier, a trig ratio compares the lengths of two sides of the triangle. So these are the two sides, opposite and hypotenuse. So it would be A over C. I like to call this, and I'll abbreviate it as OH, opposite hypotenuse. Then for cosine, cosine is always the leg adjacent over the hypotenuse. And so I'll abbreviate this as A over H. And then tangent is the leg opposite over the leg adjacent. So it's the only one that doesn't have the hypotenuse in it, and I will abbreviate that as O over A. So if you're trying to remember these ratios, oftentimes you are taught, and maybe you remember this from geometry, SOHCAHTOA. The problem with SOHCAHTOA is spelling it. You can remember SOHCAHTOA, but oftentimes you forget how to spell it. So this would be sine opposite hypotenuse, so sine opposite over hypotenuse. Ca is cosine adjacent hypotenuse. Cosine equals adjacent over hypotenuse. And then TOA, tangent over equals opposite over adjacent. So tangent equals opposite over adjacent. So how do you remember how to spell SOHCAHTOA? So I like to use the phrase some old hippie. So S is for sine, O is for opposite, H is for hippie. Some old hippie. And then next would be caught. If I can squeeze this in here, another hippie. I guess I'm not going to be able to. Hippie is going to be down here. So cot, cosine, another adjacent hippie, hypotenuse. So some old hippie caught another hippie. And then let's put this one for tangent, tripping on acid. Haha. So tripping for tangent, on for opposite, acid for adjacent. So some old hippie caught another hippie tripping on acid. That's how you can remember SOHCAHTOA. All right, so then those you might have learned in geometry last year, but then probably what you did not learn were the reciprocal functions. And all I need to do is take the reciprocal of sine, and we get what's called cosecant. Cosecant is 1 over sine, and if I took 1 over sine, I actually will have the reciprocal of OH. So cosecant is going to end up being HO, hypotenuse over the opposite. Same thing with cosine. The reciprocal of cosine is secant. Secant is 1 over cosine. So 1 over cosine is really going to end up being the reciprocal of A over H, which is going to end up being H over A. And you will have to learn, memorize, however you want to state it, that the reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. So these two seem to be pretty simple. You would think that cosecant would go with cosine, but it doesn't. So that's kind of how I remember that myself, is that cosecant does not go with cosine, it goes with sine. And so the reciprocal of tangent is O over A, or A over O. So cotangent is A over O. So these are really called inverses, which are then become the reciprocals. All right, so those comprise 6, not all, but 6 of the trig functions that you'll need to learn for next year. So let's run through how that works. So in this particular example here, you have 2 out of your 3 sides of your triangle. You really need all 3 sides. So to find this third side, and I'm going to actually make this bigger. So in order to find this third side, guess what we're going to have to use from yesterday? That's right, Pythagoras' theorem. So if you know 2 sides of a right triangle, you can always use the third side. So I'm going to call this third side x, and that's going to be our hypotenuse. So remember, a squared plus b squared equals c squared. And our legs, if you recall, are always a and b, and the hypotenuse here, x, is going to be our c. So I have 30 squared plus 16 squared equals, and I'm going to put x squared here. So 30 squared is 900 plus 16 squared is 256, and that equals x squared. So if you add 900 and 256, I'm going to switch the x squared and that sum. So 900 plus 256 is 1,156. So of course, to solve for x, we have to take the square root. And I always like to test a number this big to see if it's a perfect square. So if you take the square root of 1156, it actually comes out to be 34. How nice. So I know that x is equal to 34. So now this is my angle of reference, and I'm going to start finding my opposite, adjacent, and the hypotenuse. So I like to find my hypotenuse first. So right here, this is my hypotenuse. And that means the other 2, the legs, are going to be side opposite and adjacent. So if this is my angle of reference, opposite it is 16. And this must be adjacent, the 30. All right, so we're going to find our 16 16 are 6 ratios. So let's find sine first. So some old hippie caught another hippie tripping on acid. So I've set up my ratios. All I have to do is write my numbers in there. So opposite is 16, hypotenuse is 34. So sine becomes 16 over 34, and of course we want to reduce that. 2 goes into 16 8 times, 2 goes into 34 17 times, so sine is 8 over 17. Then cosine, adjacent is 30 over the hypotenuse is 34, so I get 30 over 34. I want to reduce that. 2 goes into 30 15 times, and 2 goes into 34 17 times. So this equals 15 over 17. And then for tangent, opposite over adjacent, so I got 16 over 30. And then I want to reduce that. 2 goes into 16 8 times, and 2 goes into 30 15 times. So for tangent, our ratio is 8/15. Now the nice thing is, once you have these three, it's easy to get these three because they're just reciprocals of these ones. So remember, cosecant does not belong to cosine, it belongs to sine. So the reciprocal of 8/17 is just 17 over 8. And then the reciprocal of cosine is 17 over 15. So secant is 17 over 15. And then finally, tangent is 8/15. So cotangent is 15 over 8. So this one is a smidgy bit smaller. This one, what they're telling you is that given the ratio for cosine, find the remaining ratios. So notice here that they've given you 1 out of the 6 ratios. So what I'm going to do with that is I am going to draw a right triangle and put in theta. And then because cosine is caught another hippie, so caught another hippie, that means that according to this, my reference angle, this is my hypotenuse. And then if that's my hypotenuse, these are my legs, opposite and adjacent. So opposite goes here. And then adjacent goes here. So we just found out that adjacent is 2 based upon what they've given us. So I'm going to put 2 into here, and hypotenuse is 3. So I'm going to put 3 here, and then that leaves us with, we don't know the opposite, so we're going to let that be x. And if I know 2 sides in a right triangle, I can use Pythagoras' theorem to find the third side. So I'm going to let the opposites here be x, so x squared plus the other leg, which is 2 squared, equals the hypotenuse, which is 3 squared. So x squared plus 4 equals 9. Subtract 4 from both sides. X squared is equal to 5. Take the square root, and so x is equal to the square root of 5. So now we know that opposite is the square root of 5. All right, so that gives us just a little bit of issues when it comes to simplifying our ratios, but we're going to figure out what our ratios are first. So I'm going to use some old hippie. We already did caught another hippie. And then we have tripping on acid. So let's get these ones. We already know this ratio is 2/3. And so for sine, opposite is the square root of 5 over the hypotenuse, which is 3. That does not need to be rationalized, so that's fabulous. And then for tangent, opposite is the square root of 5 over adjacent, which is 2. Again, that does not need to be rationalized. So then to get cosecant, secant, and cotangent, we are just going to take the reciprocals of these. So the reciprocal of sine is 3 over the square root of 5. But of course, this needs to be rationalized. Can't leave it that way. So square root of 5, square root of 5. So we get 3 square root of 5. Rad 5 times rad 5 is just 5. So complicated, but there it is. This one won't be so bad. The reciprocal of 2/3 is 3/2. So that's nice. And then finally, we're going to take the reciprocal of rad 5 over 2. So that is 2 over the square root of 5. We are going to have to rationalize that. So rad 5 over rad 5. And so 2 times rad 5 is 2 radical 5. Rad 5 times rad 5 is just 5. And there you go. So you have 2 different examples of the types of things that you might have. So then let's finally look at trig ratios in special right triangles. So we did a lot of work on special right triangles yesterday. So let's find, using all of our knowledge thus far, so remember that we had our special pattern. So on a 45-45, the legs are 1, 1, and the hypotenuse is radical 2. On a 30-60-90, the leg across from 30 is 1, the leg across from 60 is radical 3, and the hypotenuse is 2. So let's start with a 45. So I'm going to start with this as my reference angle. All right. And so if that's my reference angle, according to that 45, this is going to be my opposites. This is going to be my adjacent. And this is going to be my hypotenuse, right? And so I have some old hippie caught another hippie tripping on acid. Okay, so we might have some rationalizing to do here. So let's go ahead and start. So on this triangle here, opposite is 1, hypotenuse is rad 2. So as you can see, I'm going to have to rationalize 1 over the square root of 2. So if I rationalize rad 2 over rad 2, I get radical 2 over rad 2 times rad 2 is just 2. So the sine of 45 degrees is radical 2 over 2. You will soon learn that next year. Like, that should start to come natural to you. It's something that you'll memorize because you use it so much. Now, cosine of 45, you'll notice, is adjacent to hypotenuse. So here's my angle of reference. Adjacent is 1, hypotenuse is rad 2. So notice that I still have 1 over radical 2, which is the same thing that we just did. We don't need to rationalize it because we already know it's going to be radical 2 over 2. So why go through all that work if we don't need to show it? All right, then finally for our tangent, opposite is 1 over adjacent is 1, so it's really quite nice. 1 over 1 equals 1. So the tangent of 45 is 1, and both the sine and cosine of 45 are rad 2 over 2. Then let's move to our 30-degree angle. So our 30-degree angle is right here. And so for the 30-degree angle, opposite is going to be here. Whoops, I don't want that color. Opposite is going to be here. Adjacent will be here, and this will be the hypotenuse. All right, so some old hippie caught another hippie tripping on acid. Okay, so, sorry, the Bichel's whining. So opposite is 1, hypotenuse is 2, so that's actually not so bad. So the sine of 30 is 1 over 2, which is 1/2. All right, the cosine is adjacent over hypotenuse, so rad 3 over 2. So radical 3 over 2, and that's nice because we do not have to rationalize that one. And then finally, tangent is opposite over adjacent. That one looks like it's going to have to get rationalized. 1 over the square root of 3. So let's multiply top and bottom by the square root of 3 over the square root of 3. And so we get square root of 3. Rad 3 times rad 3 is 3. So the tangent of a 30-degree angle is rad 3 over 3. All right, so hopefully this won't confuse you terribly much, but I'm going to do the 60-degree angle on this same thing here, but I'm going to erase these, and I'm going to erase this. Oh, that's good that it all came off. All right, so let's see, this time I'm going to go with, oops, I don't want that as my angle of reference. I want my 60. And so according to the 60, opposite now is going to be over here. Adjacent will be here, but the hypotenuse will still be there. So you'll see that when your angle of reference changes, opposite and adjacent also change. So opposite of 60, adjacent, and that's your hypotenuse. All right, so let's go through our ratios. Some old hippie caught another hippie tripping on acid. Libby, hush. Libby. All right, so here we go. Opposites is rad 3 over the hypotenuse is 2. So that's not so bad. So that one does not need to be rationalized. I don't know why I couldn't think of that. And then for cosine, it's adjacent over the hypotenuse, so 1 over 2. And for the tangent, it's opposites over the adjacent, so rad 3 over 1, which is just radical 3. So none of those had to be rationalized. And an interesting thing occurs. You'll notice that on the 30, 60, 90, the sine of the 30, 1/2, is identical to the cosine of 60, 1/2. 30 plus 60 is 90. They are complementary. So complementary angles, their sine and cosines will be the same. Same thing for the sine of 60 and the cosine of 30. 60 and 30 are complementary. And notice that their sine and cosine are identical. Tangent of 30 and 60, you're not going to see that. They are not identical. But with cosine and sine, that is kind of an odd thing that does occur. All right, so that is all we have for today. So for today, you're going to do the rest of the homework sheet from last night, which is going to be questions 7 through 16. All right, let me know if you have any questions.